Let's start. So in last lecture, we have done how to evaluate partial derivatives, right? Let us have one more example based on partial derivatives. If u is equal to log of x cube plus y cube plus z cube minus 3xyz, then show that curly by curly x plus curly by curly y plus curly by curly z square of u, that should be equal to minus 9 upon x plus y plus z whole square, right? So you need to evaluate this, right? So how we will start this? I will break it. I'll write it 2 times curly by curly x plus curly by curly y plus curly by curly z. It's one time, and then like this, plus curly by curly y plus curly by curly z and u, right? Just to make it easy, either you can open this square or you can write it 2 times, right? So I'm writing it 2 times just for sake of evaluation. So when you will operate, first of all, we will solve this, right? Like you write like this, d by dx of x square, right? So what will we do? You operate this d by dx on this x square. So similarly, I'm doing this. This directly cannot go inside, right? Either you need to open this square or you need to write it 2 times, right? So now after writing this, you can take this u inside. So it becomes curly u by curly x plus curly u by curly y plus curly u by curly z. So in next step, you can write it. I'm erasing this u and I'm writing this u inside the bracket. It would become curly u by x, curly u by curly y, and curly u by curly z. Now you need to find out curly u by curly x, curly u by curly y, and curly u by curly z. So you have u function. U is equal to log x cube plus y cube plus z cube minus 3xyz. Hurry up, just take 1 minute and find curly u by curly x, curly u by curly y, and curly u by curly z. Take 1 minute and find all 3 derivatives.
Done, ma'am.
Done, ma'am.
Just take half minute more. Yes, done beta?
आप कब आए 2000
9.
2008 बच्चे हैं ये आप क्लास से लो फिर मिल लेना
Sorry beta. So yes, evaluated.
Yes, ma'am.
So who will tell me curly u by curly x?
Ma'am, may I?
Yes.
Ma'am, curly u by curly x equals to 3x square
Yes.
minus 3yz
3x square minus 3yz.
divided
Yes.
by
Yes.
x cube
Hmm.
plus y cube
Hmm.
plus z cube minus 3xyz.
Correct. Z cube minus 3xyz. Correct. I hope everybody has evaluated same. Similarly, you will find curly u by curly y That would be 3y square minus 3xz upon x cube plus y cube plus z cube minus 3xyz, right? And similarly, curly u by curly z. That would be equal to 3z square minus 3xy upon x cube plus y cube plus z cube minus 3xyz. Right? Now, you do in your notebooks, add up all three terms. This plus this plus this. Write it in your notebooks. Curly u by curly x plus curly u by curly y plus curly u by curly z. Then I'll show you in slides, right? Was your function, we have evaluated ux, uy and uz. Right, now you need to add up all these three to find curly u by curly x, curly u by curly y and curly u by curly z. So LCM would be same, right? So in numerator you will be writing 3x square plus y square plus z square minus yz minus xz minus xy. Add up all three terms. So you will be at this step. Right? You will be at this step. Now, you need to show that this total answer would be curly by curly x plus curly by curly y plus curly by curly z square of u is equal to minus of 9 x plus y plus z whole square. Because you need to show that, right? You need this factor in numerator, x plus y plus z. So what I am doing, I am multiplying this complete term, multiply as well as divide with the factor x plus y plus z. Right? Just to prove this, I need x plus y plus z factor in denominator. So what I am doing, I am multiplying as well as divide this term with x plus y plus z. So you did this multiplication and as well as division. Now, when you multiply this, x square plus y square plus z square minus xy minus yz minus zx into x plus y plus z, that would be equal to this. So they would both would be cancel out. Right? You have this identity with a x square plus y square plus z squared minus of xy minus of yz minus of zx into x plus y plus z is equal to x cube plus y cube plus z cube minus 3xyz. Right? So this complete numerator will be cancelled out with this, and what is left? 3 upon x plus y plus z. Right? Now you have evaluated this. Now at the place of this factor, you will be writing 3 upon x plus y plus z. Right? Now you will operate this curly by curly x on this plus curly by curly y on this plus curly by curly z on this. So you have written like this, curly by curly x of this, curly by curly x of this, and curly by curly z of this, x, y, and z of this factor. So now evaluate this. Tell me what will be the answer? Curly by curly x of 3 upon x plus y plus z. You can write it like 3x plus y plus z power minus 1. Now find curly by curly x of this.
Like,
Yes, beta?
no, it will be minus 3
Minus 3.
bracket
Hmm.
x plus y plus z
Hmm.
power minus 2.
Power minus 2. So can I write like this? Minus 3 x plus y plus z power 2.
Yes, ma'am.
ठीक है ना? Similarly for this and similarly for this. So you will be writing minus 3x plus y plus z square for this as well as for this as well as for this. So minus 3 minus 3 minus 3, denominator is same. So we'll be writing minus 9x plus y plus z ka square. So hence this is equal to minus 9x plus y plus z ka whole square. Is it clear? Any doubt at any step, then you can ask. Clear? Okay. Now come to the next. I hope you have done this question, you have tried this question, and I have shared answer of these questions in your WhatsApp group. Now, next. Today we will be covering next topic, that is Euler's theorem. Homogeneous expression. Homo means same, right? An expression of the form f of x is equal to a naught x power n plus a1 x power n minus 1 into y plus a2 x power n minus 2 into y square and so on plus an y power n. Expression of the form this in which each term is having degree n. Degree of this term is n. Degree of this term is n minus 1 plus 1. Ultimately n. Similarly, degree of this term is n minus 2 plus 2. N. Likewise, degree of this term is n. So each term is having degree n. So expression of this form is known as homogeneous expression or function of degree n in x and y. Right? So I will say that this is a homogeneous function of degree n in variable x and y. Right? If I'll equate this expression to any function, let's say u, so you can say that u is a homogeneous function in variable x and y of degree n. Right? So if I'm writing x square plus 2xy plus y square, this is a function of two variable x and y. Now tell me, is it homogeneous?
Yes, ma'am.
Yes. Why? Because you can observe that degree of this term is 2, degree of this term is again 2, and degree of this term is again 2. So this is a homogeneous function, right, of degree 2. If I'm writing like this, xy plus 2, will it be homogeneous? Yes or no?
No, ma'am.
No, na? Why? Degree of this term is 2, 1x, 1y, and degree of this term is 0. Right? So it is not a homogeneous. But this definition is applicable only for polynomial, right? Because this function in form of polynomial. To extend this idea, to extend this definition, we have another definition of homogeneous function, which will be like this. U is a function of variable x and y, right? U can be written as a naught x power n plus a1 x power n minus 1 y n minus 2 y square and up to yn. Same expression which we have taken in previous slide, right? We know that it is a homogeneous. So what you are doing, can I take x power n common from all the terms and I'll rewrite the expression like a naught plus a1 y upon x plus a2 y square upon x square plus and so on plus an y power n upon xn. When you will open it, you will get the same expression. Right now, like if I'm talking about like this x square plus xy plus y square. U is a function of x comma y. So what I'm taking this x square outside. So what is left inside? 1 plus y upon x plus y square upon x square. I can write this function in this form, right? So this is x power n. So this is x power n. U can be written as u is equal to x power n. And this is the complete function of y by x. This is a complete function of y by x. So what is the definition? If we are able to express given function in this form, then function is known as homogeneous function with the degree n in variable x and y. Right? If we are able to express given function is in this form, that is x power n function of y by x, then function is known as homogeneous function with the degree n in variable x and y. Right? In this, let us having this example, ux comma y, that is equal to x square plus xy plus y square. So I can rewrite it in this form, and finally I can write it x square, and this is what? This is complete function of y by x. If I'm able to express this given function in this form, then I can say that this u is a homogeneous function with the degree 2 in variable x and y. Either this form, or if I can take y outside, so it would be yn function of x upon y, because you are taking y outside. So what will be left inside? That is function of x by y. So if you are able to express given function either of this form, then you can say that given function is a homogeneous function with the degree n. Is it clear? Yes or no?
Yes, ma'am.
Okay.
Yes.
Similarly, if you are having a function in 3 variable, let us say I'm considering this function x, y, and z. U is a function of x, y, and z. So if this u can be written as, if I'm taking x outside, so I'm taking x power n outside, and function of what will be left inside. There are 3 variables. You are taking x outside. So what is left inside? Y by x, comma, z by x. Right? In case of 3 variable. जब 2 variable थे तो क्या किया हमने? X power n outside. What is left inside? Function of y by x. But here you are dealing with 3 variable. If you are writing x power n, then this function should be in terms of y by x and z by x. Similarly, what can be the other possibility? See, u is equal to x power n function of y by x, z by x. Or if I'm taking y outside, so what it would be? y power n or y power n function of x upon y, comma, z upon y, right? Or if you are taking z outside, so z power n function of x upon z or y upon z. If you are dealing with function of three independent variable x, y, z, then if you are able to express the given function either of this form, then you can say that given function is a homogeneous function with the degree n in variable x, y, and z. Right? Similarly, you can extend this idea up to 4 variable, 5 variable, and so on. Is it clear? Is it clear, beta?
Yes, ma'am.
Yes, ma'am.
Okay, so now go for this question. Just tell me which of the following function is homogeneous and which is not homogeneous. Tell me about first question. Is it homogeneous?
Yes, sir.
Yes.
Yes,
You
ma'am.
can tell because it is a polynomial, you can see that degree of each term is 1. But if I'm able to represent this in either of that form, x power n function of y by x. So if I'm taking x outside, so I can represent it like this, 3 plus 4 y by x, right? So u is equal to x 3 y by x power 0 plus 4 y by x power 1. Right? So this complete is your function of y by x, x function of y by x. I can replace this with function of y by x. And now u is in the form of x power 1 function of y by x. So u is a homogeneous function with the degree 1. Right? Now go for second question. Check whether it is homogeneous or not. If yes, then what is the degree? Yes, tell me about for this second question, whether it is homogeneous or not.
No, ma'am.
No, ma'am.
No, why not?
And because the degree for x and y will be 1 and 2 has 0.
Yes, it is the basic definition, right? Let us try another one. I have told you, u is equal to 3x plus 4y minus of 2. If I'm taking x outside, so what it would be? 3 plus 4 y by x minus 2 by x. Is it right, beta? I'm taking x outside, x common. If I'm taking x outside, then this function must be in terms of y by x. So now my question is it the function of y by x? Is it function of y by x? When I'm saying y by x, function of y by x means if you are replacing this y by x with one variable, let's say t, then this complete function should be in terms of t. Right? When I'm saying this is a function of, it should be function of y by x, it means when you are replacing y by x with t, then this function should be in terms of t. So let us check here. It is x 3 plus 4t and minus 2 y upon t. Right? So this is not a function of t. So it means this is not a function of y by x. So you cannot express this u as a x power into function of y by x. So this is not a function of y by x. So therefore u is not a homogeneous function. You know that it is not homogeneous function because of this constant term, degree of this term is 0. But this is a previous definition. Now you have learned a new definition, so you need to apply new one. And how we are applying? We are taking this x outside. What is left inside? 3 plus 4y by x minus 2 by x. Because of this term, this is not a function of y by x, right? So you cannot represent u in the required form. That is why it is not a homogeneous function, right? Now, come to third question. Check whether it is homogeneous. If yes, then tell me what is the degree. Apply new definition.
मैम हमें excuse me मैम
Yes, beta?
मैम हमें कॉमन क्यों निकालते हैं मैम
Beta, your voice is not clear.
मैम हमें कॉमन क्यों निकालते हैं
हाँ जी.
मैम मतलब मैम जैसे हम एक्स मैं कॉमन निकाला था मैम कॉमन में मैम निकालते क्यों हैं
निकालते?
मैं वेट
मैम वो पूछ रहे कॉमन क्यों निकालते हैं.
Okay. Harjinder beta, see. I know this definition. U is x square plus xy plus y square. We know the meaning of homogeneous, and I know this is a homogeneous function. Why you are saying it is homogeneous? Because degree of each term is same, 2, 2 and 2. Now, I'm asking you, can you tell me whether this function is homogeneous or not? Can you tell me, can you give me any idea whether it is homogeneous or not? No. You cannot give me any idea regarding this whether it is homogeneous or not because of meaning of homogeneous, I know in this expression degree is same, right? That is why I'm saying the definition of word homogeneous, that is applicable only for this polynomial type function. To extend this idea ki whether the given function is homogeneous or not, so that ki we can apply that definition generally, so that is why we are representing in that form. और वो form भी आएगी कहाँ से? यहीं से, because it is a homogeneous function. I'm saying. So if I can express x square 1 plus y by x plus y square upon x square. इससे क्या हुआ? This is a homogeneous function. I know it, but from this I can express the function of in this form. So what can I do? If you are having such type of function, ultimately what is it? It is a function of y by x. ठीक है? U is equal to tan inverse y by x. Tan inverse is a function, and what is the variable y by x? This is my requirement to prove a function as a homogeneous. ठीक है? Just to extend the definition, we are representing u this in this form. देखो, अगर मुझे ये पता लग गया है कि मैं इसे ऐसे एक्सप्रेस कर सकती हूँ, तो आपकी डेफिनेशन क्या हो गई? एक्सटेंड हो गई. अभी आपके पास ये फंक्शन था u is equal to tan inverse y by x. तो if I know this definition, तो I will directly say that u is a homogeneous function with the degree 0. Because I can write it like this: x power 0, tan inverse y by x itself a function of y by x. So I expressed u in the required form. So u is a homogeneous function with degree 0. Is it clear, Harjinder? Sorry, Harinder.
यस ओके मैम
ठीक है, बस हमने अपना आइडिया एक्सटेंड किया, क्योंकि पोलिनोमियल में तो यू कैन सी कि ईच टर्म इज हैविंग सेम डिग्री. अभी मैंने ऐसा फंक्शन लिख दिया तो यू कैन नॉट गिव मी एनी आइडिया, बिकॉज उसी से हमने एक ऐसी डेफिनेशन ड्राइव की है जो आप किसी भी फंक्शन पे अप्लाई कर सकते हो. ठीक है?
ओके मैम
नाउ कम टू द क्वेश्चन नंबर 3. टेल मी वेदर इट इज होमोजेनियस और नॉट.
Ma'am,
So-
can degree be in fraction and negative?
या नो इश्यूज.
Yeah, ma'am. Then it's homogeneous, and
It's
its degree is
homogeneous?
minus half.
Very good. Very good, beta. So I'm writing like this: u is equal to under root x plus under root y plus under root z upon x plus y plus z. That is equal to, I'm taking again, this is in 3 variable x, y and z. So I'm taking here x power half outside. So what is left inside? 1 plus root y upon root x plus root z upon root x divided by, in denominator you are taking x outside, 1 plus y by x plus z by x. Then u is equal to x power 1 by 2 minus of 1. And this complete function can be written as any function of y by x, comma, z by x. Because you are dealing with the 3 independent variable. So if you're taking x outside, so what is left inside? Y by x and z by x. And this complete function is in terms of y by x as well as z by x. So u is equal to x power minus half function of y by x upon comma z by x. So you are able to express given function in the required form, right? So u is a homogeneous function with degree minus half, right? Is it clear? Is it clear? Yes or no, beta?
Yes, ma'am.
Only one yes, ma'am. What about others?
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
Chalo. Good. So second was not homogeneous, third was homogeneous with degree minus half. Now, Euler's theorem. Why do we need Euler's theorem? If I'm giving you any function, let's say u is equal to x square plus xy plus y square, right? And I'm asking you evaluate this x into ux plus y into uy. So what you will do? U function is given to you. You can find out ux as well as uy, right? And then you will multiply this ux with x and uy with y, and then you can give me answer, right? But if I know the Euler's theorem, Euler theorem is applicable only for homogeneous function, right? And if you know the Euler theorem and I'm asking you value for this, if u is equal to this, you can give me the answer within one line, right? So this is the benefit of Euler's theorem. If you are dealing with the homogeneous function and you need such type of value, x, ux plus y, uy, then you can give me answer within 1 minute without any calculation, right? So now what is Euler's theorem? If u is a homogeneous function of variable x and y of degree n, then x into curly u by curly x plus y into curly u by curly y is equal to nu, right? But condition is function must be homogeneous. Can anybody give me the answer for this question? If u is equal to this, right? You need to find out the value of this x into ux plus y into uy. And I have told you what is the Euler theorem.
Ma'am, may I?
Yes, please, beta.
Ma'am, 2x square plus 2xy plus 2y square.
2x square plus 2xy plus 2y square, right now?
Yes, ma'am.
Or in other way, I can say 2u,
Yes, ma'am.
right now, because you are saying u is equal to x square plus xy plus y square. So it means
Yes.
your answer is 2u. Correct?
Yes, ma'am.
Yes. So concept is clear to you. See, u is a homogeneous function with degree what? 2. Okay? U is equal to x square plus xy plus y square. It's a simple polynomial and you can observe that it is a function of homogeneous function with degree 2. If u is a homogeneous function, then this result is true. So ultimately you need what? N. N is what? Degree. Degree is what? 2. ठीक है, U is a homogeneous function with degree n. तो हमारे इस क्वेश्चन में क्या हुआ? U is a homogeneous function with degree 2. अगर ये homogeneous है, then using Euler theorem, x into ux plus y into uy, that would be equal to n times of u. And n is what? 2. So answer is 2u. Right? Chalo, let us have proof for this. How does it comes? U is a homogeneous function. U is a homogeneous function in x and y of degree n. If it is homogeneous function, then you can express u like this, x power n function of y by x. Then I need curly u by curly x to partially differentiate this with respect to x. So what it would be? There are two functions of x, so you will be applying u into v rule. Ux, x power n as it is, function derivative f dash y by x, and then derivative of y by x would be minus y upon x square plus function y by x as it is, derivative of x power n is n into x power n minus 1. Now simplify it, minus y, x power n minus 2, f dash y by x, plus n x n minus 1 function of y by x. Right? And then you need curly u by curly y. So you need to differentiate this with respect to y. So uy, x constant, x power n as it is, f dash y by x into 1 by x. So you will simplify it, x power n minus 1, f dash y by x. Now you will multiply curly u by curly x with x and curly u by curly y with y. You will multiply this with x and this with y and then add up. So let us have it next slide. This is curly u by curly y, we have evaluated. Now we are multiplying x with curly u by curly x and y with curly u by curly y. This x curly u by curly x plus y curly u by curly y. So now simplify it, x power minus of x n minus 2 plus 1 f dash y by x plus n x power n f of y by x and then plus y x power n minus 1 f dash y by x. Right? We multiplied this x inside to minus x n minus 2 plus 1 into y. Sorry, I missed this. Y f dash y by x. Then multiply this x, so n minus 1 plus 1 x power n would be left. And then plus y x n minus 1 f dash y by x. So this term is negative and this term is positive, would be cancel out. So what is left? N x power n function of y by x. And what is it? You have supposed this is u. So that is equal to nu. This completes the proof. So you need to remember this. If u is a homogeneous function with degree n, then x into curly u by curly x plus y into curly u by curly y is equal to nu. You need to remember this. Probably condition is u is a homogeneous function. Right? Let us have example. Okay, before example, there is an extension of Euler's theorem. Euler's theorem is for first order derivative and extension of Euler's theorem for second order derivative. So again, if u is a homogeneous function of degree n in variable x and y, then see u is a function of x and y and two variables. So you can find two partial derivative, u with respect to x and u with respect to y. Right? U is a function of x and y. So two first order partial derivative can exist And for Euler's theorem, you are multiplying this with x and multiplying this with y and then add up. That would be equal to n times of u. Now I have told you Euler's theorem, extension of Euler's theorem is for second order derivative. So if u is a function of two independent variable, so how many derivative, second order derivative can exist? uxx, uyy, uxy and uyx, right? And in case of continuous function, we consider both are same. So I can count it twice. So I will write here 2uxy. ठीक है? In Euler's theorem, x को हम ux से मल्टीप्लाई करते थे, फर्स्ट ऑर्डर पार्शियल डेरिवेटिव एंड 1 डिग्री. यहाँ क्या है uxx, तो हम इसको मल्टीप्लाई कर देंगे x स्क्वायर से, राइट? यहाँ uy फर्स्ट ऑर्डर डेरिवेटिव था, तो सेम ही डिग्री से हमने इसको मल्टीप्लाई किया. तो इट मीन्स uy बाय किससे मल्टीप्लाई होना चाहिए? इट शुड बी मल्टीप्लाइड विद व्हाट?
y स्क्वायर.
y स्क्वायर. तो हमने किया इसको y स्क्वायर से मल्टीप्लाई. थर्ड टर्म हमने लिया 2uxy, तो इसको किससे मल्टीप्लाई करना चाहिए?
मैम xy.
xy, गुड. uxx था x स्क्वायर, uyy था y स्क्वायर, uxy था तो xy. बस अगर आपको ये याद है तो हम यहाँ लिखेंगे डायरेक्टली x स्क्वायर करली 2u अपॉन करली x स्क्वायर प्लस 2xy करली 2u अपॉन करली x करली y प्लस y स्क्वायर करली 2u अपॉन करली y स्क्वायर इज इक्वल टू n इंटू n माइनस 1 इंटू u. वहां क्या था? सिर्फ nu, and here it is n into n minus 1 into u. Euler's theorem is for first order partial derivative, extended Euler theorem for second order partial derivative. How you will remember it? U is a function of xy, so only two first order partial derivative exist, ux, uy. So we'll multiply ux with x, uy with y, add up, that would be equal to nu. In extension, uxx, uyy, uxy. uxy and uyx, that is why you're putting here 2. Right? Multiply this with x square, multiply this with y square, and multiply this with x and y. That is equal to n into n minus 1 into u. I hope if you remember it in this way, तो ये कभी नहीं भूलेगा आपको. ठीक है? इतना सा एक्सप्रेशन देख के हम डरेंगे भी नहीं, कितना बड़ा याद करना है हमें. Right? Now, come to the question. If u is equal to x power 1 by 3 plus y power 1 by 3, x power half plus y power half, and complete power is 1 by half, then find the value of x curly u by curly x plus y curly u by curly y. Try this question. Whenever it is asked, so first try is, can I make it homogeneous? Can I express in that form x power n into function of y by x? If it is yes, then I can apply Euler's theorem. Okay, it is not mentioned that using Euler's theorem evaluate this. Okay, it is your understanding ki can I apply here Euler's theorem? So for application of Euler's theorem, this function should be homogeneous. Now check it and tell me whether it is homogeneous or not. If yes, then what is the degree? You will try it in the similar way. Take highest x power outside in numerator as well as in denominator and then simplify it.
Excuse me.
Yes, beta.
Is it minus 1 by 12?
We will check it. Just wait. Anyone else who has done it?
Yes, ma'am. Minus 1 by 12.
Okay. I need 3-4 more answers. Ria? Ria, have you done it, beta? Ishita?
Ma'am, I am doing it.
Okay, beta. Take 1 minute, do it.
Yes, ma'am, it's -1/12.
-1 by 12. Good. Anyone else who has done it? Harinder?
मैं कर रहा हूँ।
कर रहे हो? अच्छा, कर रहे हो, चलो। Abhinav? 46, 47?
मैम एक
Anji,
मिनट
Anji beta?
एक मिनट
Your voice is not audible. Okay, let's see. U is equal to x power 1 by 3 plus y power 1 by 3, x power half, 1 by half, and total half. So in numerator, you are taking x power 1 by 3 outside, 1 plus y1 by 3 upon x power 1 by 3. And in denominator, you are taking x power half outside. So 1 plus y half upon x half, and total power is half, right? So this is the complete function of y by x. So you are writing 1 by 3 minus 1 by 2. So that would be minus 1 by 6, and then open it, multiply this power, x power minus 1 by 12 into this complete function y by x, right? So u is a homogeneous function with degree minus 1 by 12, right? U is a homogeneous function of variable x and y of degree minus 1 by 12. If u is a homogeneous function, then you can apply Euler theorem. Using Euler theorem, x into ux plus y into uy is equal to nu. What is n? Minus 1 by 12. So minus 1 by 12 into u. So this will be your answer. Right? So answer is minus 1 by 12 u. Correct? Now, next question. If u is equal to function of y by x, then find the value of x into ux plus y into uy. Yes, do it, hurry up. It's just 1 minute, 1 second answer.
Ma'am, equal to u.
No u, beta. Why u?
Ma'am, because the degree will be 1.
No, degree
Zero,
is
zero,
0.
zero, zero, zero.
Yes, degree is 0 because u can be expressed x power n into function of y by x. Function of y by x is already there. Okay, so I can write here x power 0, that is 1. So u is a homogeneous function with degree 0. So therefore answer would be 0. You can write, you can express u is a function of y by x is equal to x power 0 function of y by x. So using Euler's theorem, x ux plus y uy is equal to 0 times of u, and that is equal to 0. Chalo. Next, if u is equal to x into y, function of y by x, then find the value of x into ux plus y into uy. See, in this question, u is equal to x function of y by x. अगर ऐसा होता तो दैट्स फाइन, हम कह देते u इज ए फंक्शन ऑलरेडी फॉर्म में पड़ा है तो x की पावर 1 हुआ, u इज ए होमोजेनियस फंक्शन विद डिग्री 1. But now y is multiplied here, so this y is here. So what you can do, either this y should be in form of y by x, then only you can express it complete as a function of y by x, right? ना क्या मैं y को भी y by x की फॉर्म में लिख सकती हूँ? Because this, if I'm considering this now, so this is not function of y by x. I need to make it function of y by x. So what I need?
I'm multiply
multiplying
divide
by
by x.
Good. Multiply and divide by x. So we are multiplying this with x and dividing by x. Done. So now it is x square y by x into function of y by x. So this complete is what? Function of y by x? Sorry, it is f. Right? So this complete can be replaced by some another function of y by x. So u is a homogeneous function with degree 2. Right? So then what will be the answer? Value of this?
2u.
2u, because u is a homogeneous function of degree 2, and you know that this is equal to nu, and what is the value of n? N is 2, so answer is 2u. Now I'll show you the solution. You are multiplying and dividing with x, so it become x square, some function of y by x. So u is a homogeneous function with degree 2. So therefore, Euler's theorem, x into curly u by curly x plus y into curly u by curly y is equal to nu, n is 2. So answer is 2u. Right? Come to the next. If u is equal to sine inverse x upon y plus tan inverse y by x, then find the value of x ux plus y uy. So what you can do, sine inverse x by y plus tan inverse y by x. So I can write it this angle in form of y by x. So I'm writing sine inverse 1 upon y by x plus tan inverse y by x. This complete function of y by x. So what I need, I'm putting here x power 0. So u is a homogeneous function with degree 0. So again, answer would be 0. Right? Now, tell me the answer. If z is equal to cos y by x plus sin y by x, then x curly z by curly x plus y curly z by curly y is equal to what? Z, 2z, 3z, 0.
Ma'am, 0.
Anyone else?
I'm 0.
Okay. Niharika?
Yes, ma'am, I'm doing.
Okay. See, beta, when you are observing this complete function is in terms of y by x, no need to solve it. This complete function is y by x, so just write it here x power 0. And this complete is function of y by x. So you can write z is equal to x power 0 function of y by x. Z is a homogeneous function with degree 0. अगर 0 है तो x into zx plus y into zy is equal to 0 times of z. So answer is 0. Right? Same question है अभी. यहाँ हमने sin inverse x by y किया था. ये भी y by x की फॉर्म में था, तो इसको भी हमने y by x की फॉर्म में बना दिया, 1 upon y by x लिखकर. कंप्लीट फंक्शन इज y by x, तो हमने x पावर 0 से मल्टीप्लाई कर दिया. ठीक है. So answer is 0. Now come to next. If u is equal to log x power 4 plus y power 4 divided by x plus y, then show that x into curly u by curly x plus y into curly u by curly y is equal to 3. So again, I can use Euler's theorem. Euler's theorem is running in my mind when I saw this, right? So u is equal to log x power 4 if I'm taking outside. So it would be 1 plus y power 4 upon x power 4 divided by x I'm taking outside, 1 plus y by x. ये कट किया, क्यूब आ गया. So you are writing it u is equal to log x cube, and this is complete function of y by x. Function of y by x. Can I say that u is a homogeneous function? Can I say that? Is u in the required format as per the definition of homogeneous function? Yes or no?
Yes,
No.
ma'am.
No,
No,
beta,
no.
it's not. Why? Because log is creating problem. If log is not there, then you can say that u is a homogeneous function with degree 3. Abhi log is creating problem. So what I'll do it, I'll write taking exponential on both sides. So e power u is equal to x cube function of y by x. U is not a homogeneous function, but e power u is a homogeneous function with the degree 3. Because you cannot express u directly in this form x power n into function of y by x. So in that case, you need to rewrite it in this form. Now, this is a homogeneous function. So I will apply Euler theorem on this function, not on u. Right? See, now u e power u is a homogeneous function. So you will be writing like this, x into curly by curly x of eu, because eu is a homogeneous function now, plus y into curly by curly y of e power u. That is equal to, degree is what? 3. So 3 eu. U की जगह अभी क्या है? EU. Then you need to simplify it. X, you will differentiate this with respect to x. So e raised to power u as it is into curly u by curly x plus y e power u curly u by curly y is equal to 3eu. So eu would be cancelled out on both the sides. So x into ux plus y into uy is equal to 3. Done. So this is required. Show that x ux plus y uy is equal to 3. Whenever you are not able to show u as a homogeneous function, so we try to do some manipulation, right? So here u is not a homogeneous function, but e raised to power u, that would be equal to x cube function y by x. So e power u is a homogeneous function. So I can apply Euler's theorem on e power u. So x curly by curly x of e power u plus y into curly by curly y of e power u, that is equal to 3 e power u. Then you will simplify it, e power u would be cancelled out, and that is your answer. Right? So sometime it happens, given function as it is not homogeneous, but you can make some type of function as a homogeneous function. So this was u, e power u, it is the degree of 3. Then you can apply Euler theorem, and then answer is this. Do this question, beta. If u is equal to sine inverse under root x minus under root y upon under root x plus under root y, then find the value of x into ux plus y into uy. Now you can do this question. Check, can u be a homogeneous function? U is equal to sine inverse under root x, I'm taking outside in the same pattern, under root y upon under root x divided by under root x 1 plus under root y upon under root x. Okay, this root x would be cancel out. So now you tell me, can I say that u is a homogeneous function? Tell me, beta, is u homogeneous function?
Yes,
No,
ma'am.
ma'am.
Why not and why yes?
Ma'am, because of sine inverse, I think it could not be.
See, if there is a existence of x, see what is left now. You are writing it this sine inverse 1 minus under root y upon under root x 1 plus under root y upon under root x. Sine inverse 1 minus under root y upon under root x upon 1 plus under root y under root x u. So I can say this is a function of y by x, like tan inverse y by x. Right now? Because this x is cancel out. If suppose in your question, in numerator there is a x and in denominator there is under root x, so you will be left with x half, right? Then you cannot say that because of this factor. अभी ये फैक्टर नहीं है आपके पास, बिकॉज आपके पास यहाँ भी अंडर रूट एक्स था, यहाँ भी, तो कैंसिल हो गया. Now you can directly say that u is a homogeneous function with degree 0, right? Or other way, if you will express this like this, sine u is equal to under root x minus under root y upon under root x plus under root y. Then again you can say that sine u is a homogeneous function with degree 0. But because यहाँ x नहीं है, तो directly आप यहाँ से भी लिख सकते हो u is a homogeneous function with degree 0, x power 0. Getting my point?
Yes, ma'am.
Right, Shubham? Anyone else having any doubt? You can approach this question in both ways. Because यहाँ का x cancel हो जाएगा, तो this is a complete function of y by x. So you can write u is a homogeneous function with degree 0, or you can express this in the form of sine u under root x minus under root y upon under root x plus under root y. In this case, you will say sine u is a homogeneous function with degree 0. And here you will say u is a homogeneous function with degree 0. If you are saying this, so directly you will write answer 0. Right? But if you are saying this, then I'll show you the solution. See, u is equal to sine inverse this. You can write sine u is equal to this. This is x0, function of y by x. So sine 0 is a function of homogeneous function of degree 0. So you will apply Euler's theorem on sine u. So x curly by curly x of sine u plus y curly by curly y of sine u is equal to n sine u, or n is 0, so that is 0. When you will simplify it, it would be x sine ka derivative cos. You will write it like that. X cos u into ux plus y cos u into uy is equal to 0. And then 0 by cos u would be 0. After that, you will write in this. X into ux plus y into uy is equal to 0. Is it clear, beta? See, it is very important how you will read it. If the question is like that, u is equal to sine inverse x minus y upon under root x plus under root y. My question is this. If u is equal to this, then find x into ux plus y into uy. In that case, u cannot be homogeneous function. Because when you are expressing like that sine inverse, it would be like this: x power half 1 minus y by x upon 1 plus under root y by x. Getting my point? Because of presence of this x, you cannot say that u is a homogeneous function. In that case, you need to shift sign on left hand side and you will say that sine u is a homogeneous function with the degree half. Getting the difference, beta? Because of this, you cannot say that u is a homogeneous function. In this particular question, you need to write sine u is a homogeneous function with degree half. Okay? But in this question, you can say that u is a homogeneous function with degree 0 directly, because यहाँ का जो under root x था, that would be cancel out and this would become totally function of y by x. So it depends upon you how you are considering, but keep this mind, you will apply Euler's theorem only on homogeneous function. If you are saying u is a homogeneous function, तो आप u पे लगाओगे. If you are saying sine u is a homogeneous function, then you will apply Euler's theorem on sine function. Is it clear? Is it clear, beta?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay. Now come to the next. If u is equal to x square plus y square whole power 1 by 3, then evaluate x square curly 2u upon curly x square plus 2xy curly 2u upon curly x curly y plus y square curly 2u upon curly y square. Tell me what to do. We will apply what? This time you need second order derivatives. So I have told you one is Euler theorem, another is extension of Euler theorem. And extension of Euler theorem was this. If u is a homogeneous function, then x square uxx plus 2xy uxy plus y square uyy is equal to n into n minus 1 into u. What is n? N is a degree of this homogeneous function. So now this is your function, right? Tell me whether it is homogeneous or not. If it is homogeneous, then what is the degree?
Ma'am, it is homogeneous.
It is homogeneous. Then degree is what?
Ma'am, 2 by 3.
2 by 3. So it means you can directly put it here 2 by 3. 2 by 3 into 2 by 3 minus 1 times of u using extension Euler theorem. See, u is equal to x square plus y square 1 by 3, x power 2 by 3, function of y by x. So u is a homogeneous function with degree 2 by 3. Therefore, by extension Euler theorem, this complete expression is equal to n into n minus 1 into u. And what is n? 2 by 3. So 2 by 3 into 2 by 3 minus 1, that is equal to minus 2 by 9 times of u. Then it is clear. See, everything is based on homogeneity. If you are able to find out whether this function is homogeneous and what is the degree, then there is no issue. Right? Now, tell me this. If u is equal to log x cube plus y cube plus z cube, then x into ux plus y into uy plus z into uz is equal to what?
Ma'am, the first option.
Answer is 3.
Yes, ma'am.
Answer is 3. Correct. Let's have one more. If u is equal to x square plus y square plus z square, such that x into ux plus y into uy plus z into uz is equal to lambda u, then lambda is what?
मैम
Two.
डी
Two.
ऑप्शन.
Sorry, beta.
मैम 2.
Yes, answer is 2. Right? So that's all for today.